Hello everyone, you are welcome to my channel. Today we are going straight into the 2021 WAEC GCE Physics past question. No fluff, just a clear solution you can trust. If you are preparing for this upcoming WAEC GCE, this past question could be your secret weapon to success. Please do ensure you follow my channel for subsequent series of solution or past questions solutions. Okay, let's dive in. Here is 2021, and we're going to look at 50 questions, but we'll be breaking it down small, in order to get it straight. Okay, so we have the first question here, which says, which of the following quantity is not an example of force? Remember, it's not, so take note. So remember, since they put is not, we are looking for the odd one. So it means that only one is not an example of force. So A, we have mass, B, tension, C, weight, D, frequency. So the correct option here is mass. Mass is not force. So our correct option here is option A. So question 2 says the reason for laminating the soft iron core of a transformer is to A, reduce the eddy current, B, reduce the magnetic flux, C, increase the magnetic flux, D, reduce efficiency. The correct answer here is to reduce eddy current. So question 3, formation of hydrogen bubbles at the copper plate of a primary cell is called A, polarization, B, back EMF, C, electrolysis, D, local action. The two defects of primary cells are polarization and local action. Polarization is as a result of hydrogen formation at the copper plate, while local action is as a result of impure zinc use, right? So the correct answer here is option A, which is a polarization. So moving on, question 4 says, which of the following factors does not affect the rate of evaporation of a liquid? So A, temperature, B, volume, C, wind, D, surface area. Temperature, wind, and surface area affect the rate of evaporation. The higher the temperature, the higher will be the rate of evaporation. The higher the amount of wind, then the higher will be the rate of evaporation, and the exposed surface area also affect the rate of evaporation. So the only factor that does not affect the rate of evaporation here is volume. Volume of the liquid does not affect the rate of evaporation. I hope we are together. Question 5 says, the opening in the eyes through which light passes to the retina is called A, pupil, B, cornea, C, iris, D, optical nerve. The correct answer here is a pupil. So question 6, a heat-sensitive resistor made of semiconductor is called A, thermometer, B, thermostat, C, thermistor, D, thermopile. Thermometer is used for measuring temperature. Thermostat is to control the amount of temperature. The correct answer here is a thermistor. So question 7 said electric motor primarily converts A, electrical energy into chemical energy, B, kinetic energy into potential energy, C, electrical energy into mechanical energy, D, electrical energy into heat energy. The correct answer here is electrical energy into mechanical energy, like your electric fan. Convert the electrical energy is converted into mechanical energy that move the fan blade, right? Okay. Then question 8 says, which of the following statement about the molecules of solid and liquid is correct? They both have weak attraction. No. Solid does not have weak attraction. B, they have wide separation. No. C, they exhibit random motion. No. D, they exhibit vibration, right? Vibratory motion. Both solid and liquid exhibit vibratory motion about their mean position. So the correct answer here is option D. So question 9 says the distance between a node and an adjacent antinode of a transverse wave is equal to A, half of the wavelength, B, the wavelength, C, thrice the wavelength, D, quarter of the wavelength. Here is a transverse wave in a string, right? We have something like this. So we have the incident wave, Let's manage like this. Then we have the reflected wave. We have the reflected wave. So the distance here is node. Here is also a node, the point where there's no displacement, right? Here is also a node. While this place where you have maximum displacement is your antinode. Here is antinode. So the distance between this node to this node here is your full wavelength. Here is the full wavelength. So lambda. So the distance between this here, if this is lambda, then from here to here is half lambda, right? So here will be lambda all over 2, lambda over 2. But the node difference between node, the distance between node and adjacent antinode here is like half of the lambda, right? So that's going to be lambda all over 4, which is quarter of what? Of wavelength. Are we together? So therefore, our correct option here is option D, which is a quarter of a wavelength. Question 10 says, in photoelectric effect, the number of electrons emitted per second from a metallic surface is proportional to A, intensity of the incident radiation, B, frequency of the incident radiation, C, energy of the incident radiation, D, work function of the metal. The correct answer here is intensity of the incident radiation, right? So since they are talking about the number of electrons, remember intensity determines the number of photons hitting the surface per unit time. And each of the photons has a potential to emit or eject electron as they hit the metal surface. Are we together? But when the question says that the energy of electron, now that time it depends on the frequency, it's not on intensity. Please take note. Take note of this question because in another way around, they can say the energy of the electron emitted per second from a metallic surface is proportional to what? This time around, it is proportional to frequency. But when it is in terms of the number of electrons, it is proportional to the intensity of the incident radiation. I hope we are together. So take note of this kind of question. They can just vary this type of question and you don't have to get yourself confused. Are we together? So the correct option here in this case is the intensity of incident radiation. Are we together? So question 11 says, which of the following action will increase the capacitance of a parallel plate capacitor? A, Roman figure 1, decreasing the distance between the plate. Roman figure 2, increasing the distance between the plate. Roman figure 3, increasing the area of the plate overlap. Roman figure 4, avoiding the use of dielectric between the plate. So when you have this type of question that is related to the capacitance of a parallel plate capacitor and you're looking for the factors, I always recommend this formula for my student that C is proportional to A and inversely proportional to D. When I remove the constant of proportionality, I have C is equal to EA all over D. By so doing, from this relationship, you can see that C is equivalent to A and C is inversely proportional. C is directly proportional to A and inversely proportional to what? The distance between them. Simply mean that when there is an increase, said increase the capacitance. If the capacitance increase, then for capacitor to increase, you have to decrease the what? The distance between the plate. And also for the capacitance to increase, we have to also increase the what? The area. This is telling you that for a capacitor to increase, area has to be increased and what? And the distance between the plate has to what? Be decreased. So by so doing, now come to your options now. Number figure 4, increasing the capacitance by decreasing the distance between the plate. That is correct from this our explanation. Increasing the distance between the plate, that is wrong. Increasing the area of the plate, that is correct. So that is Roman figure 1 and Roman figure 3 as the correct option. I hope we are together. So the correct option here in this case is option A. So moving on, question 12 says, a metallic surface, a sphere, is heated from what? 27 degrees Celsius to 200 degrees Celsius without any change of state. Which of the following changes will result from the heating? A, no change occur in its volume and density. B, its volume increases and its density increases. C, its volume increases and its density decreases. D is volume increases without a change in density. So look at this option now. You can see that the whole everything is surrounding revolving around what? Volume and density. Therefore, we have three parameters here: density, volume, and and temperature. So now you can see from this figure that there's an increase in temperature. So if there's an increase in temperature, what will it result to in terms of volume and what and density? So that is the question they are asking you. So when you have this type of question here, what do you need to do? You need to look at the fact, the relationship between volume and what and density. You have density is equal to mass all over volume. Simply mean that when there is an increase in density, there is going to be a corresponding decrease in what? In volume. Are we together? So now, since and for you to have a decrease in what? In when the temperature of substance increase, definitely there's going to be an expansion, isn't it? Meaning that there's going to be an increase in volume. In terms of volume, is going to be increasing because of what? Increase in temperature. In that case, if there's going to be a increase in volume, therefore density will what? Will decrease. Are we together? So since there's an increase in temperature, there's going to be an increase in volume, which will result to decrease in what? In density. So let's look at our option. We have its volume increases and its density increases. This is wrong. Option A say no change occur in volume and density. This is wrong. Option B say its volume increases and density increases. This is wrong. Option C say its volume increases and density decreases. This is correct from my explanation. I hope we are together. So that's to say our correct option here is option C. So moving on, we have question what? Question 13 says, the acceleration of a moving object can be determined from A, the slope of its distance time graph, B, area under its distance time graph, C, slope of its velocity time graph, D, area under its velocity time graph. Are we together? So remember, what is acceleration? Acceleration A is equal to the velocity all over time. So when you use a velocity time graph, we have something like this. Here is your time axis in second, and here is your velocity axis in meter per second. Is that correct? So remember, your acceleration is like an inclined slope moving up, increase in what? In a velocity with respect to what? Respect to time at a particular point in time. So now here is your slope. Remember from your basic mathematics ingredient, here is your slope, and that is your acceleration. So your slope is used to determine the acceleration of velocity of a moving object can be determined using the slope of the velocity time graph. Are we together? So the correct option here is option C. Option C. Are we together? So please hope you are following. If you're not following, just pause it and go back a little bit and watch it. Trust me, you are going to understand it. So the next question says, a student wishes to measure the potential difference across a resistor R. She has a galvanometer G and some connecting wires. What else does she need? What else does she need? So if you have this type of question, what needs to come to your mind is this: to measure potential difference. What do we use to measure potential difference? Can you remember? Okay, that is a voltmeter. We use voltmeter to measure potential difference. And resistor is there. Then she has galvanometer. That's to show that she wants to convert this galvanometer into a voltmeter. Are we together? So conversion of galvanometer into a voltmeter, how do we do that? That is what the question is asking, nothing more. So in order to convert a galvanometer into a voltmeter, galvanometer into a voltmeter to voltmeter, what do? We connect a high value resistor in series with the galvanometer. Here is the high value resistor, right? Then you connect it in series with the galvanometer. That is all. We have converted this to what? To I've converted this galvanometer into a voltmeter. So in that case, what is your correct option here? We connect a high value resistor, otherwise known as a multiplier, otherwise known as a multiplier. If it is a galvanometer to ammeter, what do? We convert it, we connect a low value resistor, otherwise known as a shunt, in parallel with the galvanometer. Please take note of that. So our correct option here in this case is option D, high value resistor connected in series with G, which is galvanometer. So that's about question what? Question 14. Question 15 says, the handle of a screw jack is 35 centimeter long and pitch of the screw is 0.5 centimeter. What force must be applied at the end of the handle to lift a load of 2000 Newton if the efficiency of the jack is 30%? You're asked to take pi as 22 all over 7. Now, we have this type of question. They say the handle of a screw jack is this. That is the radius. So your radius R is given to be 35 centimeter. And the pitch, P, is given to be what? 0.5 centimeter as well. And given that the load, L, to be lifted is 2000 Newton, and the efficiency is given to be what? 30%, and pi is given to be 22 all over 7. So now remember our formula in machine that efficiency is equal to mechanical advantage all over velocity ratio multiplied by 100. So remember, since the machine used here is a screw jack, then what is the velocity ratio for a screw jack? Remember, each machine has their respective way of calculating the velocity ratio. So for a screw jack, velocity ratio is given to be 2 pi r all over pitch. So by so doing, you're going to have 2 multiplied by 3.14, which is that 22 over 7, multiplied by the radius, which is 35, all over pitch, which is 0.5. When you do this, multiply the numerator and divide by the denominator, you should end up having 440 as your velocity ratio. When you have that as your velocity ratio, then the next things to do is to find the mechanical advantage, because what we asked to find, which is the force used, need to be applied, which is the effort. We need mechanical advantage before we can get effort. Remember the formula that mechanical advantage is equal to load all over effort. Let me distinguish it. Let me use number E. So without mechanical advantage, you cannot get effort. So from this formula, we can get our mechanical advantage. So efficiency is equal to mechanical advantage all over velocity ratio multiplied by 100. So what is our efficiency, which is 30, equal to mechanical advantage all over velocity ratio is 440, then multiplied by what? 100. So 0, we cancel this 0. Then if you multiply this implies I have mechanical advantage multiplied by 10 is equal to this one crossing to this side, that is cross multiply, isn't it? Make this one over 1, cross multiply half 30 multiplied by 444, isn't it? Because 0 has cancelled this 0. Therefore, mechanical advantage will be equal to 30 multiplied by 44, everything divided by 10. That will be 1,320 divided by 10. So our mechanical advantage will now be equal to 132. Remember, it has no unit. So when I've gotten your mechanical advantage, you can come here now and use this formula. Mechanical advantage is equal to load all over effort. So what's our mechanical advantage? 132 is equal to load, which is 2,000 all over effort. So therefore, our effort is equal to 2,000 all over 132. And if you do the division, that should give us a 15.2 Newton. So 15.2 Newton, which is option C. So our correct option here is option C. I hope we are together. So moving on, question 16. Question 16 says, the inductive reactance in a circuit of a frequency 100 Hz is 1 ohms. The inductive reactance at is XL, that is XL, right? The inductive reactance. Are we together? Okay. So the inductive reactance XL is given to be 1 ohms. Is given to be 1 ohms. And the frequency F is given to be 100 Hertz. The frequency is 100 Hertz. You are giving pi to be equal to 3.14. Exactly. So Remember, we are asked to calculate the inductance of the inductor, that is L. We're looking for the inductance of the inductor, that is L, right? So remember, this is a question from AC circuit, and here what we have is inductor as the resistor, as the opposition to the flow of what? Of the AC current. So remember this relationship that what? That your XL, the inductive reactant, is equal to 2 pi FL. Exactly. And you're looking for L, therefore L will be equal to XL all over 2 pi F. So that will be equal to 1 all over 2 multiplied by 3.14 multiplied by frequency, which is 100. So that will give us 1 all over 1 all over, when you multiply everything together, that will give us 628. That will give us 628. So what is 1 divided by 628? That should be 1.59 times 10 raised to power minus 3 Henry. So that is option what? Option B. The correct option here is option B. I hope we are together. So the next question says, the diagram above or below illustrate the velocity time graph of a body. Calculate the distance covered by the body during the motion. We're looking for the distance covered by the body throughout the motion. So the distance covered is the area under the graph. So the distance covered by this is area under the graph. We're looking at this area under the graph, this one. This is first area under the graph, which is look like a rectangle, right? So the next one is a trapezium. This one, are we following? This one is the another area, which is a traperion. So that's what you're going to look. We find the area of the rectangle, find the area of the trapezium, then you add them together. That will give you your total area or the total distance covered by the body during the motion. Are we together? So by so doing, look at it. You can say that distance covered is equal to area under the graph. So what is the area under the graph? The area under the graph is area of the square. Is it square? Yes, it looks like a square. Yes, it's going to be area of the square, right? Of the squared plus what? Area of trapezium plus area of trapezium. Area of trapezium. Good. So now here, the area of trapezium, the square, let's name it A, here B, C, D. Then from here I said E, then I have what? F. So the area of the square is going to be equal to length times breadth, which means maybe AD multiplied by what? Multiplied by either AB or AC, because they are equal. Multiplied by AB, let's say AB. That is length and breadth, right? So from here to here is 4, as you can see here, and from here to here is also 4. So that will give us 4 times 4. Let's continue. Plus area of the trapezium. Remember, area of trapezium is equal to half the sum of the parallel side. What is the parallel side? This side here, right? Let me use another marker. This side here, this one, this side is parallel to this side. I believe you know what is parallel. So this side is parallel to this side. Is that clear? So the parallel side here is CD plus the EF, then multiplied by the height. What is the height here? This is the height of the trapezium from here. That is DE, multiplied by DE. Yes, DF rather, DF. So in that case, from here, I have A times AD, which is 4 times 4. I have 4 times 4. I hope you know how I get the 4 times 4. AD, that is from this 0 to this point is 4. You can see this 4 here. And from 0 up here in the velocity axis, from here to this point is also 4. Remember, this is our shape, right? So it's 4. That's how I get 4 times 4. Then plus 1 over 2 into CD is this height from D to C is CD, and it's 4 also. So I have 4, then plus EF. EF is this height from this point to this point. And if you trace it, that's going to be 10. So I have plus 10, then multiply by what? DF. DF is the distance from here to here. Here is 4, here is 12. That's going to be 12 minus 4. So 12 minus 4 to give us what? 8. I hope it is understood. So this will be equal to 16 plus 16 plus 1 over 2 multiplied by 14. 4 plus this, that will be 14. Then multiply by what? Multiply by 8. So when you do that, you're going to have 16 plus 56. 16 plus 56. 16 plus 56, that should give us 72 meter. So we have our answer to be 72 meter, which is option C. I hope this is understood. So question 18 says, an atom that emits an alpha particle may become a daughter of a different element, become a different isotope of the element, become a daughter with an increasing mass, become a daughter of a different element. It become a daughter of a different element. For instance, if you have element A having a mass number of, let's say element X rather, X having a mass number of A, an atomic number of Z, when it disintegrates and emits a beta particle, alpha particle, which is a helium nuclide having 4 mass number and 2 atomic number, it will get to another nuclide, another daughter nuclide of what? Having a decrease in the mass number by 4 and a decrease in the atomic number by 2. Is that clear? So this is a daughter nuclide, right? Are we together? So it will have become a daughter of a different element, element X, Y in this case, having what? A decrease in the mass number by 4 and a decrease in atomic number by 2. So the correct option here is option D. I hope we are together. So question 19 says, which of the following unit is equivalent to electric current from this unit? What is electric current? Electric current I is equal to charge per unit time. I hope I'm not mistaken. Charge per unit time. So what is the unit of charge? Coulomb. What is the unit of time? Second. That gives us unit of what? Coulomb per second. So which is what? Option A. So option A is the correct answer. So the next question says, question 20, question 20 says, a ball is swung in a horizontal cycle of radius r with a constant speed. What is the direction of its acceleration? This is a circular motion, and in a circular motion, the acceleration is always toward the center. So the correct answer here is what? Is C, is toward O, which is the center of the cycle. I hope we are together. So we are going to stop here into this class. In our next class, we continue from question 21. I hope you enjoy this class. Please ensure you subscribe to the channel in order for you to be notified each time I drop a new series of solution. Thank you for your time. God bless you.